Okay, this is the concept number 9, which is multiplying polynomials. Okay, so it's just same polynomials as we were dealing with in the last section, but now you are multiplying. Now you've got to be really careful with these because it goes back to your exponent rules. Okay, so it's not the same rules as when we were adding and subtracting on the last pretest. Multiplying goes back to using your exponent rules from a few sections ago. First, if you're multiplying a monomial and a monomial together, so remember that's a single term times another single term. You are multiplying the coefficients first. -3 times 7 is a -21. Then you have an x times x. Now remember, this goes right back to the exponent rules. And technically, we did this in the exponent section, so you should be okay with this monomial times a monomial. X times x is an x to the first times an x to the first. Same base. Shortcut is to add the exponents. So you have an x to the second power. So your final answer is a -21 x to the second power. Same thing with the second example. 2x to the third times 5x to the second. 2 times 5 is 10. X to the third times x to the second is an x to the fifth. Remember the shortcut, when the bases are the same, you can add the exponents. Now, regardless of whether there's parentheses here or the dot in between them, these are both multiplications. So just because they look a little bit different doesn't change how you approach the problem. If there are two sets together with parentheses, that means they're being multiplied. If they have a dot in between them, that means they're being multiplied together. Then we have product of a monomial and a polynomial. So I'm taking a one-term item times some other polynomial that maybe is 2 terms, 3 terms, 4 terms. What you're really doing, if it's a monomial times something else, you're distributing. So I'm taking, in this first example, I'm taking this x that's out front, and I am multiplying it times my binomial of 7x squared plus 4, which means I have to distribute it in. X times 7x squared is a 7x to the third power. I have an x to the first and an x to the second, gives me an x to the third. Then x times 4 is a positive 4x. So your final answer is 7x cubed plus 4x. And again, those are not like terms, so you cannot combine those together. Then in the second example, we have a -2x times a trinomial of x to the third plus 9x plus 1. Same idea. You're distributing this -2x to each one of these terms. -2x times an x to the third power is a -2x to the fourth. -2x times a 9x is a -18x squared. Again, you're adding the exponents for the variables and multiplying the coefficients. -2x times 1 is just a -2x. Okay, be very careful with your signs. Negative times a positive is still a negative. Negative times a positive is a negative. Negative times a positive is another -2x. So be very careful with your signs. Okay, 3 more examples here that just cover those same topics. We'll go through them quickly. We have 4x times this -2x squared minus 3. Distribute that in. So you have a -8x to the third power minus a 12x. Okay, so you're just distributing this 4x to each term. Same thing in number 2. I'm distributing a -x to each one of this trinomial. So you get a -x to the fourth minus 5x squared plus 10x. Here I have a monomial of a 2x to the third times a polynomial. You have 4 terms here, okay? But it's the same process. This monomial has to get distributed to every single one of these terms. So you end up with a 2x to the sixth plus 6x to the fifth minus 4x to the fourth and then plus 10x to the third. All right, now jumping to multiplying binomials together. It's still distributing, except for now you're going to distribute twice. So in this first example, excuse me, we have to do this x has to get multiplied times the x and times the negative 5. So I'm distributing this x to both of the other set of parentheses. Right? It does not get multiplied times this 4. You only multiply it times the pieces in the other set of parentheses. So x times x, and then x times a negative 5. That gives us x squared minus 5x. Then I do the same thing with this 4. I distribute it to the x and to the negative 5, which gives me a 4x minus 20. And then you're just combining like terms. So we're going to write it out in one single row and combine like terms. My only like terms are this negative 5x plus 4x, which is a negative x in the middle. I still have an x squared minus x minus 20. So you're taking the first set of parentheses and you're distributing each piece of it to the second set of parentheses. So it's just distributing twice. In the first example here, we have 2x minus 4 is being multiplied times x plus 5. So again, you start by distributing that 2x to the x, and then distribute the 2x to the 5. When you do that, 2x times x is 2x squared. 2x times 5 is a positive 10x. Then you have to take this negative 4 and distribute it. So we're distributing it a second time. Negative 4 times x is a negative 4x. Negative 4 times 5 is a negative 20. Always check for like terms. So I have a positive 10x minus 4x that are my like terms. Highest power comes down first, so I have a 2x squared. Then this is going to give us a positive 6x, and then you bring down your negative 20. In the next example, be really careful here. Okay? Don't make these harder than they have to be. Remember that anything to the second power is just telling you to multiply it by itself. If I give you 4 squared, it would be 4 times 4. If I gave you 12 squared, it's 12 times 12. So 5x minus 3 squared is really 5x minus 3 times 5x minus 3. That just means I'm multiplying it by itself. Okay, now when you do that, that turns into a binomial times a binomial. So you take this 5x, distribute it to the other 5x, which is a 25x squared. Then 5x times this negative 3 is a negative 15x. Now I take this negative 3 from my first set and I distribute it. So that's going to give me another negative 15x. And then negative 3 times a negative 3 is a positive 9. Combine like terms in the middle. So my highest power still comes down first. It doesn't have any like terms. Then negative 15x minus 15x. Be very careful with your signs. Negative 15 minus 15 is a negative 30. Okay? It does not cancel out. It is not 0x. Use your calculator if you're unsure. Negative 15 minus 15. And then the positive 9 comes down. All right, let's look at the back. We want to find the product of these 3 examples. Those are just 3 more of the same kind that we just looked at. So you can go ahead and follow through theirs, but it's just binomial times a binomial. So you distribute the first piece to the second set, distribute the second piece to the second set. Okay? There's another squared example here where you have to rewrite this out as 4y plus 2 times 4y plus 2, and then do your double distributing. Now, last part. If we are multiplying a trinomial and a binomial together, okay, it's still the same thing as the last part that we just did. Okay. Whichever parenthesis is written first, you have to take every piece of that first parenthesis and multiply it times every piece in the second parenthesis. Okay, and then combine like terms if you have them. So here, my first set of parentheses is x squared plus 2x plus 1. So each piece has to get distributed to every piece in my second set. So I start with the x squared, go right in order. So x squared has to get multiplied times x, which is x to the third power. X squared has to get multiplied by 2, which is 2x squared. That's it for the first piece. Now I do the middle piece. 2x has to get multiplied by x, which is 2x squared. 2x has to get multiplied by 2, which is a positive 4x. Now you multiply the 1 times everything. 1 times x is just x. 1 times 2 is just 2. Okay, so each piece of this first set of parentheses had to get multiplied by the x and had to get multiplied by the 2. Now you're just going to combine like terms. Again, start with the highest power. So x to the third is my highest power. I'm going to write it first. Then I drop down to my x to the second. So I have a 2x squared plus another 2x squared is 4x squared. Combine our x to the first power is 4x plus 1x is a 5x. And then the 2 just carries down to your answer because it doesn't have any like terms. All right, a couple more down here. Another example, we have a binomial first times a trinomial. So again, each piece of this first set of parentheses has to get multiplied times each piece of the third set, or of the second set. 3b gets distributed to b squared, which is a 3b to the third power. 3b gets distributed to the 6b, which is 18b squared. 3b gets multiplied to the negative 7, which is a negative 21b. And you do the same thing with this negative 4. You have to distribute it to each piece in that other parenthesis. So negative 4 times b squared is negative 4b squared. Negative 4 times 6b is a negative 24b. And then negative 4 times negative 7 is a positive 28. Again, combine like terms like normal. Same thing with this bottom example. You have a trinomial times a binomial. So you're distributing each one of this first set to each piece of the second set and then combining like terms. Now, this last example is really important, and you guys tend to struggle with area and perimeter. You have a formula sheet that has these formulas on it for you. Do not guess at what the area formula is. Do not guess at what the perimeter formula is. If you're unsure, look it up. These types of problems will be on the keystone. Right? You will be given that same formula sheet for the keystone, so use it to your advantage. Do not just guess at these formulas. Make sure that you're calculating them correctly. So with this shape, we know that it's a rectangle. Okay? They tell you the length is 2x minus 3. They tell you the width is x plus 4. Okay? We have two pieces. We first want to write an expression that represents the area of it. Okay? The formula for area is length times the width. So I'm taking this length times the width. 2x minus 3 times x plus 4. All it is a binomial times a binomial. Take this 2x, distribute it to the x and the 4. Take this negative 3, distribute it to the x and the 4. And then combine like terms. Now the second set is asking you for the perimeter. Truthfully, you have multiple different ways of doing perimeter. Okay? Perimeter means the distance around the outside of it. Okay, so how far would it take me to walk around the outside of this fence? Okay, that's what you're asking. That's what you're trying to figure out, is how far is it the entire way around? A lot of times when they do this, they're only going to show you 2 of the sides. You have to remember that it's a rectangle, so it has 4 sides. You have to add this x plus 4 to the other side. This 2x minus 3 also goes to the other length. So your actual formula for perimeter is 2L plus 2W. So 2 times the length plus 2 times the W. You have 2 places to distribute here. This 2 gets multiplied in here. This 2 gets multiplied in, and then you combine like terms. Okay? Or you ultimately could write this out and do 2x plus 3 plus 2x plus 3 plus x plus 4 plus the other x plus 4. Okay? Regardless, you will still get to the same answer for the perimeter. Okay? But again, use those formula sheets. Do not guess at these formulas. They're very simple problems as long as you write down the formula correctly. All right, again, this is your concept number 8, and it's concept number 9, the multiplying polynomials.